Okay, YouTube, welcome back. This is going to be my second video with my series of videos about trying to make a full computer out of just transistors. So this video, as you saw probably on the description, that this is going to be for a half adder and a full adder. And so in a minute here we'll talk about what that is, and this is how we're going to add numbers, binary numbers, with transistors. So stay tuned. Okay, so if you remember from the last video, we had an AND gate that gave us those outputs, and we had an XOR gate that gave us these outputs, right? 0, 1, 1, 0. So we're going to put these two gates together to make what's called a half adder. Half adder, and you can look at the circuit here. You can pause it if you want to build it. My circuit's not the best. I got a little scribbly scratch here and there, but you can see that our output, we're now going to have two inputs, input 1 and input 2. You see them here, A and B, and then just these are tied to A and B because I couldn't draw it through here. And we're going to have two inputs and two outputs now. We're going to have our output 0, 1, 1, 0, and we're going to have our carry 0, 0, 1. And if you notice, this is the same output as the XOR, and this is the same output as the AND gate, right? So we're going to combine them. And so we're going to count in binary. 0 plus 0 equals 0, right? 0 plus 1 equals 1. 1 plus 0 equals 1. 1 plus 1 equals 2. Well, in binary, we can't put a 2 here. We have to carry a bit over, just like we do a decimal, right? So now we have 1, 0. That's 2. So 1 plus 1 equals 2. That's a binary 2. And so we just added two numbers using this. So that's a circuit we're going to build. And you can go back and look at the XOR gate. You can see this is an XOR. This is that's an OR. Oh, this is your AND right here. This is our XOR. This is our AND gate tied together. So let me get the actual circuit set up and we'll test it. Okay, so you can see here I built this half adder circuit. I have, where'd my little screwdriver go? I have input 1 and 2, and I have LEDs as my two outputs. And so you can see here I have, let me get a little closer. 1 and 2 are off. Off, 0 plus 0 is 0, right? And now we have 1. 1 plus 0 is 1. Turn that one off. Turn input 2 on. Also, 0 plus 1 is 1. And if I turn them both on, 1 plus 1 is 2. 1, 0 in binary. So see that? We just counted these and gave an output of what we counted. We counted up to 2. Right? So that's pretty cool, right? So, but to go over 2, if we wanted a third column, now we need a full adder. This is only a half adder. So let's take a look at the full adder. Okay, so here's the truth table for a full adder. And as you can see, we have our half adder all the way to here, right? All the way to here. But now we have this extra, our third input. This is our carry in, and this is our carry out. So from here up is the half adder that we had, right? Here's our exclusive OR gate, and here's our AND gate, right? But now we have a third column down here. So we basically just put another here's what the schematic. So here's one thing is there's several ways to build a full adder and even a half adder, I think. You know, you can use different logic gates and put them together any way that you can come up with to give you your, you know, truth table so that it works out, right? But from the videos I saw, this looked like the easiest way to fit it on a breadboard. And this is all using NAND gates. If you remember the NAND gate, where's the NAND gate? Right here. Here's the NAND gate. And it's a pretty simple gate to build, right? So this whole thing is just using NAND gates. And then so this is the way my drawing, you could pause the video and try to figure that out if you're feeling like it. Anyhow, but you can see here, there's an AND gate, there's an AND gate, there's an AND gate, AND gate. They're all just tied together. The outputs are going from this NAND gate to these two. So you can see this output is going to these two, just like it shows here, right? So these are all just NAND gates. And then my paper, because of the way I drew it, this point A connects to here. And then here's 4 more NAND gates. And then the last NAND gate down here, which would be the carry out NAND gate. So let's take a look at what it does. So it's the same thing here. We have 0, 0. 0 plus 0 plus 0 equals 0. 1 plus 0 plus 0 equals 1. 0 plus 1 plus 0 equals 1. 1 plus 1 plus 0 equals 2, right? We already figured that out. But now 0 plus 0 plus 1 equals 1, because now we have a third column. So still 1 equals 1. Now we have 1 plus 0 plus 1 equals 2, right? It's kind of the same thing that we did up here. It's just the carry from the previous adder, right? We could have multiple full adders, and so the previous adder is going to have a carry out, and it's going to go to the carry in of this one, right? So 1 plus 0 plus 1 is 2. 0 plus 1 plus 1 is also 2, right? But now we have 1 plus 1 plus 1 is 3. And this is how you count 3 in binary. You have a 1 in the 2's column and a 1 in the 1's column. That's 3. Does that make sense? So that's our truth table for our full adder. This is the logic gate, and here's the actual schematic that I built. It's ugly. At some point, maybe we'll try to figure out some software for drawing a schematic and printing it so it looks nicer, easier to follow. These resistors are all 2.2K. Here's what I built on the breadboard, though. This looks a little better, right? See, it looks like a lot, but it's really not if you just go through it step by step. You can see here are my 3 inputs. 1, 2, and 3 are A, B, and C. My 3 inputs. Here's my 2 outputs. So let's see if we can add numbers up to 3. All right, let me turn power on. Okay, we got 5 volts. Now, you can see we have 0 plus 0 plus 0 equals 0. Let's see, I gotta do this with my finger. 1 plus 0 plus 0 is 1. 0 plus 1 is 1. 0 plus 0 plus 1 is also 1. But if we have, let's see, we'll leave that one on. So now if we have 0 plus 1 is 2. See how that changed? So 1, 0 to 2. See? 1 and 2 equals 2. And if I turn this off and this one on, it also equals 2. 1 plus 0 plus 1 is equal to 2. And if I turn all 3 of them on, which is 1 plus 1 plus 1 is 3, which is 1, 1 in binary, just like the truth table says. Pretty cool, right? So we added 3 digits in binary and came up with 3, 1, 1. So, so this will be the half and full adder video. Let me know if you want to see anything different, but we're going to continue from here. Now we're gonna put several of these together to make longer digits, right? So we can make bytes. We can add bytes. So stay tuned for that video. That's what I'm going to work on next. I'm going to work on putting multiple full adders together. Okay, a couple things before I go. One is Anne's always telling me that I underestimate the prices that I pay for things, and she was right. It wasn't $17 for this little scope. was $37. Still like super cheap, right? That was one thing I wanted to bring up. And the other was what? Hang on a second. Okay, the other thing was I wanted to mention a couple of the YouTube channels that I'm watching and I'm following along with this. One is a guy's name's Ben Eater. Another one's called Global Science Network. They're both really good videos, really good channels that have some really good videos on this, so maybe go check them out as well. And also there's quite a few others that I'm looking at too, but those are two that are really doing the kind of thing I want to do. So, all right, thanks for watching. Stay tuned for the next one. Bye.